Welcome to this talk. So my name is Chin. I'll introduce myself in a second, but I just wanted to go through a couple of things, important things about what we're trying to achieve from this next half-ish hour. So first of all, I've decided to go nuts. So this is slideless talk. So we're going to see how that works out. I think the other important things are the target outcomes. So basically from the end of this talk, I would really like to enable you to and/or replicate today's environmental investigation, reuse today's code for other investigations you may want to do, and/or pick up transferable skills for other related data science applications, so data journalism, citizen science, education, and so forth. And the way we're going to do that is by trying to semi-live code an end-to-end data science workflow that generates a data visualization of this. Okay, so without looking at the URL and the bar, does anyone have a sense? You can just shout out because, you know, we've run out over time. Anyone got a sense of what this might be? It's England data. Our apologies to, you know, Wales, Scotland, Northern Ireland. Anyone have any idea what environmental issue we might be looking at? I'm sorry, you're going to have to really shout. No, interesting though, maybe that's the color scale. This is in fact sewage spills in England over 2022. So, I mean, we'll just, I would also actually suggest, it might actually help you, you know, your choice. You are able to look this up. This is literally a GitHub page. You can tell I'm a I'm a data scientist, not a web developer. If you go to this link, I'm only going to show it to you once now, I'm sorry, because then I have to go into the Jupyter Notebook. So if you go to pickaside.github.io, then this is the link to it here, the sewage maps. So I'd really like you to investigate your own issues because, you know, this is the good part, you know, investigating, looking at the insight. I mean, I'll just kind of, just give you a sense of what the, what the visualization is. So this is sort of my area. Obviously, I'm not going to dox myself and tell you where I live. But I, for example, discovered that here, Thames Water, although they obviously get paid to deal with my wastewater, here at Houseworth Bridge, they released 4 hours of sewage in 2020. Here at Putney Bridge, that was 10 days worth of sewage. And then there's some right here. Now, you think, well, does it really matter? Are we swimming? Well, you know, people row here, they fall into the water. This is a actually very important wetland center right here. So anyway, so from public health perspectives, from your value for money, for, you know, ecological reasons, you know, I thought sewage spills is an interesting issue which should affect, or, you know, people in this room could care about it for different reasons. Anyway, so we're going to make that visualization. I'm going to try from open government data. So this open government data, or specifically this open government data, and Python. Good, I said Python, not C++ or something. Wrong conference. Okay, audience check. So your kind of awareness, can I just get a sense? Do people know what a storm overflow is? Just generally, yes? Kind of? Okay, so I'm just going to tell you, when we reference storm overflows, I mean, I'm not an expert, in this field, but, you know, again, this is the whole point of citizen science. Apparently, a storm overflow is, okay, so this is from Southern Water, so they've obviously, let's say, tempered this down a little bit, but basically, your pipes have some sort of outlet so that if there is a storm, the wastewater plus the storm water overflows, right? But this is a sewage spill, okay? So let's not mince our words. I should also point out that you can, of course, make sewage maps. You know, that data is open source. So the Rivers Trust, for example, have made their own map, which I did get slight inspiration from. You can see you can get the data for Wales and, okay, maybe not Scotland. Well, a little, no, actually not. But this is not proprietary. This is not open source. This is Esri, which is ArcGIS, which is a very dominant commercial player, let's put it this way, and I don't think it's cheap. So again, Python will give you value for money, all that kind of good stuff. Right, so who am I? So my name's Chin, I told you that. I've got sort of 15 years experience in sort of various data scientific practices, half of which was doing R, moving into Python, yay, in public sector civil society work, first government, then education, and now environmental advocacy. My digital footprint is huge, so this is me back in 2017 as a head of data science. This is some of the educational kind of outreach work I have been doing with my startup. That's me. And then now into, environmental advocacy. So anyway, I'll reference this later as sort of things that you can do after this talk, hopefully. Right, if I've done my job correctly. Okay, step A. I'm really sorry, speech to text people. This is probably really not helping you prepare. So I'm just going to give you a sense of where we're trying to go in the next 25-ish minutes. So these are sort of steps. They are kind of general and specific, right? So these are some general data science steps that you could use for other, for example, environmental investigations. And then there's a specifics of how we're going to apply that to investigate, sewage spills. Okay, so, right, step A, set up Jupyter Notebook. So you would probably import stuff, third-party packages and submodules. This is an auto-completion magic command that is very useful. And then this is just some pandas and matplotlib configurations. So when I said live coding, this is how we're going to live code, because otherwise this actual workflow probably takes about an hour. Step B, access and load data. So you're going to read into the government data. As per that link I showed you from DEFRA. The only thing I've changed is that they had frozen screens, so I unfroze them. That's basically it. And then we're going to transform that into a pandas data frame, like that. This is the, please no errors, please no errors. Phew. Okay, step C, inspect your data. Okay, this one I can type, because this is really short. So, okay. So this is your effectively kind of published data set. So there's obviously various rows. Well, okay, we'll talk about how many there are in a second. Loads of columns. These names they are unwieldy, so we should tidy that. And then we also just want to check if I can spell correctly. Live coding. What a good idea. Shape. So this will give you the number of rows and columns. So what does this mean? 14,580. So 26 is the number of columns. That's fine. Interpretation. So water and sewage companies report a total of 14,580 occurrences over 2022 in England where they legally spilled sewage. So that's cool, right? High-level sense check of the data frame. So just going to use some auto-completion, because that's what it's there for. So we're going to do a group by and then a size. Specifically, we're going to group by the water company name. Okay, so there we go. This is a bit of sense check. So these are the water companies, 10 water companies who have reported themselves spilling sewage in England in 2022. And then this is the number of records. So the number of rows, which would therefore be the number of spills. So again, already from this, you can see there's some interesting things. I mean, obviously, they serve different, populations. So, there's no like-for-like comparison. But, just from eyeballing, you can already see Thames Water, which is mine, are thankfully not awful. But, well, anyway, there's duration, so we would have to look at that as well. Anyway, step D. So prep the data for exploratory data analysis, which I'm going to call EDA. So this is a really long section. Depending on how we do for time, we might start going through it very fast. But basic data cleaning. Oh, I also should point out, in case people are kind of new to data science, and I highly recommend it as a field, it is true what they say. Data science is like 85% cleaning, wrangling, munging, whatever you want to call it. And then literally the actual, create the interesting visualization takes seconds. So I'm sure it makes for a really fascinating talk. We'll see, you can tell me. Make a copy of the data frame to prep. We're going to reset the index, which is the ID of the rows. Then we're going to drop columns we don't need, and there are a lot of them. Then we're going to rename columns so they're a little bit more user-friendly. And then we're going to check the column types. So, okay, cool. So what's interesting about this, or useful? So some of these things matter more than others. The water company object, I tell you, is a data type which will contain strings. So basically, probably a lot of these are strings. Some of this matters, some of it doesn't. This matters, the total hours spilled, because we cannot add strings together meaningfully, so we really have to deal with that. The count is also not useful as a string, but we're actually not doing, as you can see, we're actually not doing much with the count data because I thought it was more important the actual time. So, great. We're not going to talk about that. D1, handle the NaN values in data. NaNs, just in case people don't know, or would like to know, is refers to not a number, which is a common missing data representation. So let's find out the total number of NaNs in our data frame. Okay, so again, some of this matters, some of it doesn't. Obviously, the water companies submitted this data, so hopefully they know their own names, so that's fine. This is an issue, the location. If we don't know where it is, we can't plot it. And you can already see, I should just point out, data quality issues. Let's undo that. So you can see from this map, like this, I don't know if Yorkshire Water really, I mean, who knows, Victorian plumbing, but yeah, some of this is not right and would need to be tidied. Anyway, maybe that's the government needs to be looking into that, who knows. So yeah, this we need to deal with the duration. So in order to do that, we're going to drop the record where the spill location NGR value is NaN. We're going to reset the data frame index. We're going to fill the NaN values with 5/60, so i.e. 5 minutes. Again, it's an approximation, but this is just part and parcel of wrangling. You have to make adjustments. Fill NaN values in the count spills column with 1, i.e. 1 spill, and then find out the updated total number of NaN values in each column. Okay, so this is cool. This looks right. So we've taken out this row, right? So a lot of these, that row actually also had NaNs in everything else. So once we take out that, everything else, which wasn't 0, should drop. So that looks correct. So that's gone. Great. And then this is now gone to 0, which is great. And that is also 0, which is not totally relevant, but still useful. So now we're going to clean the column, the total hours spilled, which, as I said, is really the key. So that's what determines, the colors and the size of these markers. So compute a histogram frequency table of the total hours spilled column values to see what the most common spill durations were. Okay, I think I have just about enough time to actually do some coding. Oh, not like that though. So we're going to do the value counts, and then we're just going to do the top 50 because there are a lot, and that will crash my computer. So basically, in this data set, the water companies have helpfully reported 0 in terms of duration for 2,290 records, which is clearly not correct, but fine. Again, just something to note. Downplaying somewhat, are we? I reference it down here. This is where we put those NaNs have now, a lot of them gone into this. There probably are some actual 5-minute spills, but this is overinflated, but we need that. What other things to note? This is clearly a misspelt NaN, so we're going to have to deal with that. So anyway, that's that insight. Now we're going to convert the data type of the total hours spilled column from object to string, and also tidy up white space. So that is effectively to tidy up white space. And then find the total hours spilled values that don't match a decimal or whole number regular expression. So basically, we want to look at the values which they look like decimal or whole number in strings, because then we can convert it. So I'm going to run that. So this is what the strings which are not in a decimal or whole number format look like. Okay, we have 10 minutes left, so I'm really going to whack through this. Okay, so basically we're going to deal with those, is basically what I'm going to tell you, by replacing those values with, again, 5 minutes in string format, and then that means that we can turn this duration column into numeric. So as you can see, numeric, hurrah. Okay, D3, we're going to sense check, interpret the data. I'm going to skip this section mainly. We might go back to if we have time. This is just your kind of sense check and get sort of some rough insights. So now that we've got that total hours spilled column into numeric, we can now, find things out. So here we go. In 2022, these 10 water and sewage companies discharged sewage across England for approximately 1,755 and 46 hours in total, which is roughly equivalent to 200 years. So I bet our wildlife is very pleased from that. Okay, we are not going to do other stuff. Maybe this quickly, because technically you have seen the final visualization. This is just to show you that you can make subplots. Actually, not really that with too much difficulty, and those subplots can start telling you some interesting things. So United Utilities look pretty bad. I'm sorry if they're your supplier. And let's also just see which is the worst spill in this data set. So no surprise, it's utilities, and it's probably that. Okay, I'm going to whip through this section. Approximate total time spilled. This is basically creating this column, which gives you this data, so some sort of interpretation of the hours in a kind of more meaningful unit. Okay, so don't worry. Oops. What did I say? Here. Okay, yeah, we're good. No, stop doing that. Unhelpful. Right. So this is basically giving you this. The way you could do this, you know, there are plenty. I just did a, you know, if else, blah. So that's cool. Okay, now we're going to clean the geolocation data. I don't have too much time to do this, but I'm just going to try and show you. This is like good national grid reference data, okay? We can plot this insofar as we can turn these values into these lat long values, which are then plottable, okay? So that's all we need to do, that we're trying to achieve in this section. The point here is that the values are not in that kind of nice format. We've got all this weird stuff, extra spaces. We need to deal with that. So I'm just going to whip through this. How you could do that, I mean, to be fair, actually in the original CSV or Excel, you could, of course, just manually do that. This is a Pythonic version, but it is, this is very specific, and I wouldn't say this is a general, because the way you'd handle it would be specific to your data and your skill set. But anyway, it's tidy now. So we're also going to now turn that NGR data into lat long. Again, I'm not going to tell you too much. Oh, 5 minutes left. Exciting. The way I've done this is create a function and then apply that function. That's basically what I'm going to tell you, because it doesn't really matter. You can obviously follow this workflow specifically, but now you have lat long, okay? Great. So now we actually get to the, the tail end, business end maybe. So we're going to convert data structure from data frame to geodata frame to do the plotting. Why do I keep doing that? So unhelpful. So you need the GeoPandas extension of pandas, which is super. So what that will do is create basically a version of the original data set, but with geometry. That geometry now means you can plot stuff on a really nice map. We're also going to create the marker radius column, which is what determines the size of those markers. Why do I keep doing that? Oh my gosh, no. Oh no, if I can't do this, it's really going to be a pain. Oh no. How am I going to do this? Okay. I knew I was doing so well up to this issue. Sorry, I'm just going to try and I did not know my drag and drop abilities were going to scupper my talk. Okay, cool. So basically, this is just so you can get integer values. You could do this lots of different ways. Okay, yay, create the actual data set, the data visualization. Oh my gosh, we actually got to this point. Oh no, I'm going to have to copy this again, aren't I? Okay, anyway, I'm going to stop trying to, you don't need to see me try and copy and paste, because that is basically this. That's all you basically need to know. And I think with that, I think we're going to wrap up and go for questions, is basically what we're going to do. Thank you so much for your time and attention.
there, and
thanks. That was a brave attempt. Thank you.
Thank you.
Didn't quite make it. In West Wales recently, a lady spent a week in hospital on antibiotics after swallowing sewage, basically, released from this kind of outfall. I love your focus on data. When can we see consequences for all of this and a fix to the problem? Do you have any ideas?
Do I have ideas? Well, so I think the good thing is, to some extent, I mean, when I planned to do this, okay, I'll try not to give you a whole summary, but when I planned to do this was before the kind of public have now become, it has become much more of a public issue. So now, so for example, I mean, if you did a quick DuckDuckGo or other search engine search, so you can actually see, actually a lot of those water companies are now being investigated for illegal spillage. So it's actually worse than we're seeing from the data, that actually a lot of these are not, these spills were not actually, well, I can't say it. It is possible that a lot of the spills were not released during a storm. So it's basically dry spills. So I think the good thing is that thankfully it is being picked up on. But I think, if I'm honest, I do still think that, you know, Pythonic data-driven visualizations like this, I think are quite helpful in addition to, you know, existing maps like this. Because whilst obviously Love Rivers Trust, you know, this is great work, but I would actually, again, it's not a competition, but, you know, this information I don't feel is as user-friendly, as you can see, doesn't actually bring up anything, as something like this. So, yeah, I think, sorry, the answer to that question is, people are aware, but I still think citizen investigation like this can still help, you know, local people, for example, lobby, you know, I mean, especially in the upcoming, you know, in the face of an upcoming general election, you know, like this is an electoral issue that like people are looking at. So, sorry, I hope that answered the question.
any more questions? Yes, go there.
Hi, thank you. This is really cool. Have you already done this so we don't get against rainfall data?
Have I already done this? I'm sorry.
Have you combined this with existing publicly available rainfall data?
Rainfall data. No, really, really good suggestion. That would be a really good next step. I'll definitely think about doing that for another talk. But yeah, exactly. I think layering that onto other things. So, for example, population density. Obviously the weather conditions. All those sorts of things will start to give you a better insight of like how bad, you know. It's obviously not just the duration. Although what would really help is if they actually had volume, because duration, you don't know if that's just like a trickle, right? Or like a, you know, we don't actually know how big those storm overflow stars are. But yes, the idea of using more data is always good, at least in my book. So yeah, thank you for the question.
Thank you. And more questions? I have a very quick, right at the back.
So I was just going to ask, this is obviously based on the data that we have. Is there a way that you have to sort of represent data that we might not have? Here's what they might not be logging, that sort of thing. Is there a way to sort of present that with the data we do know about?
Are you talking about this specific investigation as in, or is it sort of like a, okay, yeah, because I would say in general, yes, there's definitely, I'd say as a data scientist, maybe you already know, but there's always like the approximation. So yeah, as you say, I think with this, I think you could definitely get hold of, or make some proxy. I have a feeling the water companies probably won't give more data. I mean, they already have given so little data in this already, but I have a feeling you could get data from more sort of civic data, which is publicly available. So for example, census, which would be able to give you proxies, which would then be able to, you know, layer on information which we don't for sure have. But yes, sorry, I think that answered it, sort of.
Thank you. And another question?
Can I just make a really quick point that if you are into environmental investigations, which I really encourage you to do, if you want to see kind of other environmental investigations, not a plug, but generally because this actually has 3 hours worth of tutorials, then this is the tutorial I did at PyCon in March, which has like pangolin trades, carbon pollution in the US, from universities. And the last one is deforestation in the Amazon. So, sorry. Oops. Thank you.
Okay, thank you, Chin.